Now it's time to talk about Newton's third law of motion. So let's quickly see what does the Newton's third law state. It states that to every action there's always an equal and opposite reaction. And this is the most popular law of Newton. Most time you see people say that to every action there's equal and opposite reaction. So that means for every force which is exerted on an object, there's an equal and opposite force which is being exerted on that object. So this law is the interesting one. Let's suppose this boy Ronnie is holding a ball, and by holding the ball he is exerting some force on the ball. So the ball will also exert an equal and opposite force on Ronnie's hand. So that's what Newton's law third law stated. Now the force which is being exerted by the ball by this boy, which is exerted by this boy and the ball, that's known as action, and the force which is being exerted by the ball in return, that is called reaction. So let's suppose if you are having an object O and we apply an external force F on it. Now this external force is your action. Now when you apply force F on it, this object will exert an equal and opposite force on your hand. And this force which this object exerts in opposite, that's called reaction, because it is replay of action. So when we talk of Newton's third law, you must think of an example, the apple falling down the tree. This is the most famous story related to Sir Isaac Newton. Once so happened, Newton was sitting under the apple tree and an apple fell on his head. This made him think that what attracted apple. And as soon as the apple was detached from the tree, why did it fall on the ground? Because it was attracted by the earth. Now the question which arose in his mind was that if the apple is being attracted by the earth, is not the earth attracted by the apple? So with this small observation he started digging into force and motion, and he came up with these three famous laws of motion which cover the entire classical mechanics. Even in this case also, yes, of course, the force is being exerted by the apple as well. But the difference is that since the mass of Earth is very large, therefore the force experienced by the apple is large, whereas the force experienced by the Earth is very less because the mass of apple is very small as compared to the mass of Earth. And that is what I told you, that if the mass is higher, the force needed to move that object is also more. So mass of the Earth is so huge, so you need a lot of force to make it move. Will that same small apple be able to exert that much force? No, right? That is why the apple moves, because the force experienced by apple is by the earth. So the earth can exert a large force on that small apple and the apple can move. But that small apple cannot exert that much of the force that can move the earth. So as I mentioned before also, we'll talk about action and reaction forces. So action and reaction forces always act on different bodies. It is a very interesting thing to remember. Say action for force will act on this object O by your hand, and the same force will act on your hand, okay, as a reaction. So different bodies are here, object O and your hand, two different bodies are here. So action and reaction forces occur at the same instant. I mean, there's no time lag between action and reaction. As soon as force is applied on an object, immediately a reaction will be applied in the opposite direction. So action and reaction forces occur almost at the same instant. Now, many people think that the relationship between action and reaction is same as cause and effect relationship. That means first action occurs and only after that reaction occurs. But it's not like that. An action and reaction occur at the same instant. So an important thing to remember is that there is no cause effect relation between action and reaction. Cause effect relation means, as I said, many people have this misunderstanding that action is the cause which give rise to reaction. So reaction is the effect, but it's not like that. As soon as there's an action, there's a reaction at that same instant. So action and reaction occurs at the same instant, and they act on two different bodies, or you can say they act on two different on different bodies. if action is FAB, that is force exerted by A on B, then reaction would be minus times FBA. Minus because it is in the opposite direction. Reaction is in the opposite direction, and it is equal. That's why equality is there. And FBA is the force exerted by B on A, but in opposite direction. This was all about Newton's third law of motion.